Hello, and so I begin my third session. Yep, we're recording. Yeah, let's go. Where were we? Okay, multiplication division. I think I finished the practices, and yeah, that's where I left off. Multiplication by tens. Yeah, let's go.
Let's multiply 4 times 80. So we can look at this a few ways. One way is to say 4 times we have the number 80. So we have the number 80 one time, 2 times, 3 times, 4 times. 4 times we have the number 80.
Just gonna get my
and we could do this computation, add all of these, and get our solution. But let's look at it another way. Let's try to stick with multiplication. And one way we can do that is to break up this 80. We know a pattern.
But am I recording? Yep, I am.
For multiplying by 10. So let's try to break up this 80 to get a 10. So if we have 4 times, and instead of 80, let's say 10. 8 times 10. Because 80 and 8 times 10 are equal. Those are equivalent. So we can replace our 80 with 8 times 10. And then we have this times 10 back here, which is super helpful because there's a nice neat pattern in math that we can use to help us with the times 10 part.
Ooh, times 10.
So let's start to solve this. 4 times
the
8
zero thing, I guess.
is 32. And then we still have 32 times 10. And then we can use our pattern for multiplying by 10, which is that any time we multiply a whole number times 10, we take that whole number, in this case 32, and we add a 0 to the end.
Yep.
So 32 times 10 is 320. And there's a reason that pattern works. We went into it in another video, but here just real quickly. 32 times 10 is 32 tens. And we can do a few examples. If we had, say, 3 times 10, that would be 3 tens, or a 10 plus another 10 plus another 10, which equals 30, our whole number with a 0 on the end. If we had something like 12 times 10, well, that would be 12 tens. And if we listed out 10 12 times and counted them up, there would be 120. It would add up to 120, which again is our whole number with a 0 on the end. Our 12 with a 0 on the end.
Cool
so we
trick.
can use that pattern here to see that 32 times 10 is 32 with a 0 on the end. Let's try another one. Let's do something like, let's say 300 this time. We'll do hundreds instead of tens, times 6. Well, 300 we can break up like we did with 80 in the last one, and we can say that 300 is 100 3 times, or 100 times 3. And then we still have our times 6 after that. So these two expressions, 300 times 6 and 100 times 3 times 6, are equivalent because we replaced our 300 with a 100. And then from here we can multiply. And let's start with our one-digit numbers. Let's multiply those first. 3 times 6 is 18. And then we still have 18 times 100, or 18 hundreds. So we can write that as 18
with 2 zeros.
And then to show hundreds, we'll put 2 zeros on the end, or 1800. Just like up here, just like we saw that 300
Old trick.
is equal to 3 times 100, or our 3 with 2 zeros on the end. Well, same thing here. 18 times 100 is 18 with 2 zeros on the end, or 1800s. So 300 times 6 equals 1800. Let's try another one, but this time let's go even another place value and try thousands. Something like 7 times 7,000. So like in the previous ones, we're going to break up our
Holy crap,
thousands.
I don't even know 7 times 7.
7,000 is the same as 7
My guess is
times 1,000.
49? No?
1,000 7 times. And we still have our times 7 in the front here to bring down. And again, we can multiply our single digits first, our one-digit numbers. 7 times 7 is 49.
Oh,
and then 49 times 1,000 is going to be 49,000, which we can write as 49.
Yeah, it's pretty cool.
And this time, maybe the pattern's becoming clear.
Awesome.
We're going to have 3 zeros on the end. So it'll be a 49 with 3 zeros, or 49,000.
Yep, that's true.
Just like up here, 7 times 1,000 was a 7 with 3 zeros. 49 times 1,000 is a 49 with 3 zeros, or 49,000. Let's look at this as a pattern. If we show this as a pattern, let's do something like 9 times 50. And then in another one, let's do 9 times 500. And in one last one, we can do 9 times 5,000. I encourage you to pause here and see if you can work these out. See if you can come up with solutions for these three expressions. Now we can work them out together.
Yo, I don't even know 9 times 5.
50 will be the same
4?
as 9
No. Wait, what did he say?
times 5 times 10, because we broke up our 50 into a 5 times 10. And then if we multiply across, 9 times 5 is 45. And to the end, we're going to add 1 zero. The pattern for times 10 is to add 1 zero. We can keep going here. 9 times 500 will be 9. And then times 5 times 100. 500 is 5 hundreds, just like 50 was 5 tens. Multiplying across, 9 times 5 still equals 45. But this time, we will add 2 zeros to the end, or 4,500. And finally, 9 times 5,000 will be 9 times 5 times 1,000, because 5,000 is 5 thousands, or 1,000 5 times. Working across, 9 times 5, 45. And this time we add 3 zeros. So 45,000. So when we multiply each of these expressions, we can see the only thing that changed was the number of zeros on the end. So the pattern, anytime we multiply a whole number times 10, we add 1 zero to the end of our number. Anytime we multiply a whole number times 100, we'll have 2 zeros. And times 1,000, we'll have 3 zeros. And once we know that pattern, we can use it to help us with questions like this, where initially we don't see a 10, a 100, or a 1,000, but we can get one. We can break up or decompose these numbers to get a 10, or 100, or 1,000 to help us solve the problem.
Let's see if we can figure out 3 times 60. Well, there's a couple of ways you could think about it. You could literally view this as 60 3 times. So you could view this as 60 plus 60 plus 60. And you might be able to compute this in your head. 60 plus 60 is 120, plus another 60 is 180. And you'd be done. But another way to think about this is that 3 times 60 is the same thing as 3 times. Instead of thinking of it as 60, you could think of 60 as 6 times 10. 3 times 6 times 10. And when you're multiplying three numbers like this, it doesn't matter what order you multiply them in. So we can multiply the 3 times 6 first and get 18, and then multiply that times 10. And 18 times 10 is just going to be 180. It's going to be 18 with another 0. So this is going to be 100, 180. Now, the more practice you get here, you'll realize, hey, I could have just said 3 times 6 is 18, but I have to worry about this 0 right over here. So I'm going to put one more 0 at the end. It's going to be 180. Same answer that we got right over there. Let's do another one of these. So let's say we want to multiply. Say we want to multiply 50 times 7. And I encourage you to pause the video and think about it yourself, and then unpause it and see what I do. So 50, well, there's a couple of ways you could think about it.
So
one, you could literally try to add
first,
50
so
7 times. Adding 7 50
then
times would take
10,
forever.
50.
But you could literally say 50 plus 50 plus 50 plus 50. Let's see, that's 4 plus 50 plus 50. Let's see, that is 6. I'll do one more right over here. 50 right over here. So this is 57 times. If you add together, 50 plus 50 is 100, 150, 200, 250, 300, 350. So you could do it that way, but you could imagine that there is an easier way to do it. You just need to realize that 50 is the same thing as 10 times 5. So we could write this as 10 times 5, and then we're multiplying that times 7. Once again, the order that we multiply does not matter, so we can multiply the 5 times the 7 first. We know that that is 35, and we're going to multiply that.
By
we're going to
10.
multiply that times 10. 10 times 35, well, we're just going to stick a 0 at the end of the 35, is going to be equal to 300, 350. Now I want to do that 0 in that same color. Is going to be 350.
Purple.
Now, you might realize, hey, look, I could have just looked at this 5 right over here, multiplied the 5 times the 7, and have gotten the 35, and then not forgetting that it's actually not a 5, it's a 50. So I have to multiply by 10 again, or I have to throw that 0 at the end of it to get that 0 right over here. So 50 times 7 is 350.
Cool.
Let's multiply 40 times 70. So 40
Grill.
times we have the number 70.
I don't.
So we
No,
could
you
actually
need
list
to
that out, the
introduce
number
yourself.
70, 40 different times and add it up. But that's clearly a lot of computation to do, and there's got to be a faster way.
Yeah, we just
So
do the 4
another
times
way is to
7,
stick
right?
with
So
multiplication,
it's gonna be 28.
But
and
see
then
if we
add
can
it to
break
zeros.
these numbers up, this
2,800.
40 and this 70,
I think that's how
decompose them, break
this
them
video
up in
gonna
some
go.
way to get numbers that might be a little easier to multiply with. For me, multiplying by 10 is the easiest number because I know the pattern to add a 0. So I'm going to break up 40 and say instead of 40, 4 times 10. 4 times 10 and 40 are equivalent. They're the same thing, so I can replace the 40 with a 4 times 10. And then for my 70...
Am I recording? Okay, I'm recording. I'm 12 minutes in.
Same thing, I can break this up and write 7 times
My hair
10.
sucks.
7 times 10. So these two expressions, 40 times 70 and 4 times 10 times 7 times 10, are equal. They're equivalent, so they'll have the same solution. But for me, this one down here is simpler to work out because of these times 10s, so I'll solve this one knowing that I'll get the same solution as I would have for this top expression. So what we can do is we can reorder these numbers in a different order to again continue making this question easier for us to solve. Because in multiplication, the order doesn't matter. If we have 5 times 2, for example, that will be the same as 2 times 5. They're both 10. 5 2s or 2 5s, either way it's 10. So we can change the order of the numbers without changing the answer. So again, we're going to change our expression a little bit, but what we're not going to change is the solution. So I'm going to put my 1-digit numbers first. 4 times 7.
Times 10
And then
times 10.
I'll put the 2-digit numbers, the 10s, times 10, and the other times 10. So we have all the same factors, all the same numbers in both of these expressions. They've just been reordered. And now I'll solve going across. 4 times 7 is 28. And then we have 28 times 10 and times another 10. Well, the pattern for times 10 that we know is when we multiply a whole number like 28 times 10, we will add a 0 to the end. 1 0 for that 0 and 10, because 28 times 10 is 28 tens. 28 tens, or 280. And that multiplied 28 times 10, and then if we multiply by this other 10, well, we have to add another 0. Multiplying by 10 adds a 0, so if we multiply by 2 tens, we add 2 zeros. So 28 times 10 times 10 is 2800, which means that this original expression we had, 40 times 70, also has a solution of 2800, or 2800. Let's try another example where we're multiplying tens like this. Let's do something like, let's say maybe 90
I'm gonna write along.
times, how about 30? 90 times 30. So the first thing I'm going to do is break up these numbers so that I have tens.
I guess just one
because
700.
again, for me, tens are easier to multiply than numbers like 90 and 30. So for 90, I'll write 9 times 10. And for 30, I'll write 3 times 10.
7,000.
The expressions are equivalent. We've just written it in another way. And now I'll reorder these numbers to put the one-digit numbers first. So 9 times 3. And then I'll put the tens times 10 times 10. Because we need to have all the same numbers even if we change the order. So we have the 9, 3, the first 10, and the second 10. And now, finally, we multiply. 9 times 3 is 27. 27 times 10 will be 27 tens, or 27 with a 0 on the end. And 270 times 10 will be 270 tens, or 270 with a 0 on the end. So going back to the original question, 90 times 30 is equal to 2,700, or 2,700.
Cool. Multiplying one-digit numbers
Let's talk
by
about
10.
multiplying by 10, 100, and 1,000. There's some cool number patterns that happen with each of these. So let's start here with something like 4 times 10. One that maybe we're comfortable with or already know. 4 times 10 would be the same as saying 4 tens.
Not 40.
4
oh shit, okay.
tens.
4 tens.
And 4 tens,
4.
one way we could represent that is a 10 plus a second 10 plus a third 10 plus a fourth 10.
That's going to be like 10
or
fours.
4 tens. And now let's count that.
Yeah, it should be 4 tens.
10 plus 10 is 20, plus 10 is 30, plus 10 is 40. So our solution is 40, or a 4 with a 0. And this is the pattern that we've seen before.
Yep.
When we multiply 4 times 10, we keep our whole number of 4, and we add a 0 to the end for the times 10. So another example of that might be something like 8 times 10. Well, 8 times 10 is the same as 8 tens. And this time, let's just count them. If we count 8 tens, it'll be 10, 20, 30, 40, 50, 60, 70, 80. So when I counted 8 tens, the solution was 80, or an 8 with a 0 on the end. So times 10, when we multiply a whole number times 10, the pattern is that we end up adding a 0 to the end of our whole number.
Yep.
So let's take now what we already know about tens and let's apply it to hundreds. Something like, let's say, 2 times 100. There's a couple ways we can think about this. One way is to say that this is the same as 2 hundreds. 2 hundreds, which is 100 plus another 100. There is quite literally 2 hundreds, which is a total of 200, or 2 with 2 zeros on the end. Now we have 2 zeros on the end. Or another way to think about this is 2 times 100. Instead of saying times 100, we could say times 10 times 10. Because 10 times 10 is the same as 100. And 2 times 10, we know is a 2 with a 0 on the end, which is 20. And 20 times 10 then will be 20 with a 0 on the end. Because we multiplied by 10 twice, we added 2 zeros. And multiplying by 100 is just that. It's exactly that. It's multiplying by 10 twice. So if times 10 adds 1 0, then times 100, or times 10 twice, adds 2 zeros to our answer. And we can go even further and think about thousands. Let's try something like 9 times 1,000. Well, we could think of this as 9 thousands, and if we have 9 thousands, then we have 1,000, 2,000, 3,000, 4,000, 5,000, that was 5, 6,000, 7,000, 8,000, 9,000. So when I counted 1,000 9 times, our solution was 9,000. Or looking at the numbers, a 9, our original whole
my eyes
number,
are giving up on me.
with 3 zeros after it. So 9 times 1,000 is 9,000, or 9 with 3 zeros. And we can go back to what we did before, thinking about this in terms of tens. We've worked out why multiplying by 10 adds a 0. So let's think about 1,000 in terms of tens. 1,000 is equal to 10 times 10 times 10. 10 times 10 is 100.
Okay, audio
And 100 tens is 1,000. So instead of 1,000, we can write 10 times 10 times 10. These are equivalent. And so when we multiply a number times 10, we add a 0. But here we're multiplying by 3 tens, so we add 3 zeros. So let's look at that all as one pattern. Let's say something, let's take 7, the number 7, and let's multiply it by 10, by 100,
by 1,000.
and by 1,000, and see what happens. 7 times 10 is going to be 7 with 1 0, because we have 1 10. 7 times 100 will be 7 with 2 zeros, because again 100 is the same as 10 times 10. So this is 7 times 10 twice, so we have 2 zeros. And 7 times 1,000 will be 7,000, or 7 with 3 zeros, because 1,000 is equal to 10 times 10 times 10, or 3 tens. So we add 1, 2, 3 zeros. And so we can see the pattern here. When we multiply by 10, which has 1 0, we add 1 0 to the end of our whole number. When we multiply a whole number times 100, which has 2 zeros, we add 2 zeros for hundreds. And for thousands, when we multiply by 1,000, we'll add 3 zeros to the end of a whole number.
That is true. Oh, now we have dividing.
In this video, we're going to think about what happens when we multiply or divide by 10, 100, or 1,000. So let's just start with an
Why
example.
is this stop?
Let's say we want to figure out what 237 times 10 is. Pause this video and see if you can have a go at it.
Yeah.
All right.
it's
Well, one way to think
2070.
about it is this is 237 tens. So if I put my place values here, so this is the thousands place, this is the hundreds place. I'm just not writing it out in words just to save space. Sometimes you'll see it written out as the word thousands and hundreds. This is the tens place, and then this is the ones place. Well, if I were to just say 7 tens, I would put the 7 over there. If I were to say 37 tens, I would write it like this, because 30 tens is 3 hundreds. And if I were to say 237 tens, I would write it just like that, because 200 tens is 2 thousands. And so what just happened? Well, all of my digits shifted one place to the left. So what used to be in the ones place is now in the tens place. What used to be in the tens place is now in the hundreds place. And what used to be in the hundreds place is now in the thousands place. But what's in the ones place? I have to put something in the ones place. Well, we no longer have any ones in this product, so we would just put a 0 there. So 237 times 10 is 2,370. Now, one way to think about it is when I multiplied by 10, I really just I put a 0 right over here at the end of this number, but it's important to realize that what really happened is I shifted all my digits one place to the left. But what if we were to go in the other direction? What if we were to take, 450, and we were to divide it by 10? Well, you could imagine if multiplying by 10 shifts the digits one place to the left, then dividing by 10 is going to shift the digits one place to the right. And so we have a 4 in the hundreds place, we have a 5 in the tens place, and we have nothing in the ones place. And so what used to be in the hundreds place will now be in the tens place. So I will put that 4 right over there. And then what used to be in the tens place is now going to be in the ones place. So I will put that 5 over there. And we had nothing in the ones place. If we did, and this is a little bit out of this video's purpose, but you could start to think what might happen if this was not a 0. But we have 450 divided by 10 is 45, and it is indeed 45. Now another way to think about it, other than the fact that all of the digits shifted one place to the right, is that we removed this right 0 here when we divided by 10. Now let's extend that. Let's say that we had 359 times 100. Pause this video and see if you can figure out what that is going to be. Well, there's two ways that you could think about it. You could just think of it in terms of this is 359 hundreds. So let's put some places here. Let's say this is the 10,000s place. This is the thousands place.
Man, my eyes are giving up on me.
This is the hundreds place.
My coffee isn't working its magic.
And this is the ones place. So if you were to say 900s, you would go right over there. If you were to say 5900s,
your brain sucks today.
Like that, because 50 hundreds are 5,000s. And if you were to say 359 hundreds, well, 300 hundreds is 3 10,000s. And of course, in this scenario now, you would have no tens and no ones. And so what we see happened is all of the digits shifted two places to the left. What was in the ones place is now in the hundreds place. What was in the tens place is now in the thousands place. And what was in the hundreds place is now in the 10,000s place. And so this product is 35,900. Now another way you could think about it is, this is the same thing as 359 times 10 times 10. And we already know that every time you multiply by 10, you shift your digits one place to the left. So if you're going to multiply by 10 twice, you're going to shift all your digits two places.
Oh, the
left,
girl teacher
exactly
is different. She wants to
based
add
on
0.
That, what do you think? What do you think, or based on everything?
Same result, but
what do you
different
think?
Concept.
If I were to take
I don't know what to say, but you know what I mean.
5,000, and I wanted to divide it by 100. What do you think this is going to be? Pause the video.
Okay, so it's going to be 750.
All right. Well, we've already seen if you divide by 10, you shift the digits one place to the right. And dividing by 100 is really the same thing as dividing by 10 twice. So we really just need to shift all our digits two places to the right. So what used to be in the 10,000s place is now going to go to the hundreds place. What used to be in the thousands place is now going to be in the tens place. And what used to be in the hundreds place is now going to go into the ones place. And so what we are going to get is, instead of 7 10,000s, we're going to get 7 hundreds. Instead of 5
tens place where it's going to go?
We are going to get 5 tens. And then instead of 0 hundreds, we will now have 0 ones. So this is equal to 750. Another way to think about it, and we've talked about it before, if you're dividing by 100, and if you have some of these trailing zeros here, well, then you would remove 2 of these right trailing zeros. but it's really important to know why that happened. Now,
It's true.
you've hopefully seen a pattern, so I'll ask you two more questions. Let's say that someone were to walk up to you on the street and say, "Hey, you, what is
Oh shit, that's a lot. I think 164,000.
times 1,000?" And they would also ask you, "What is 98,000?" I'll just say 98,000 divided. Well, I'll say 198,000 divided by 1,000. Pause this video and see if you
Okay,
can.
198.
All right, you've probably seen the pattern now. Just as
Yep.
multiplying by 100 was multiplying by 10 twice, multiplying by 1,000 is multiplying by 10 three times. So this is equal to 164, and I'll color code this, times 10 times 10 times 10. So what we're going to do is shift all the digits 3 places to the left. So instead of 164, this 4 is no longer in the ones place. It is now in the thousands place. It is now in the thousands place. And that makes sense. If you take 4 ones and you multiply it by 1,000, you're going to get 4 thousands. What was in the tens place is now in the 10,000s place. And what was in the hundreds place is now going to be in the 100,000s place. And so in order to represent this number, I have to put something in the hundreds place. Well, I have no hundreds now. I have to put something in the tens place. I have no tens now. And I have to put something in the ones place. So this is going to be 164,000. And once again, that's consistent with the pattern we saw. We've added 3 zeros to the right of this number. So similarly, what's going to happen over here? Well, we're going to shift all the digits 3 places to the right. So the 1, it's going to go 1, 2, 3 places to the right. So what was in the 100,000s place is going to go into the hundreds place. What was in the 10,000s place is going to go 1, 2, 3 places to the right. It's going to go into the tens place. And what was in the thousands place is going to shift 1, 2, 3 digits to the right. It's going to be in the ones place. Or another way to think about it is when we divide by 1,000, especially when we have these 3 trailing zeros, those are going to go away. So instead of 100,000 here, this is just going to be 100. Instead of 90,000 here, or 9 10,000s, this is just going to be 9 tens. And instead of 8,000s, this is just going to be 8. So it's equal to 198.
Cool. Okay. So, mic test. Oh, it's working, and I'm on for only 30 minutes. Okay, let's start. Man, my eyes. Your brain is shit right now. Wait, what the freak? That's really weird. Oh my god. Oh shit. I multiplied it times 300. Yeah, I'm really feeling sleepiness right now. So 70 equals 10. Man, this shifting of the quality symbol thing. See? It's confusing. See, now it's on. Okay, maybe it's part of practice or something. Okay, so we're gonna retake that. Oh my gosh! It's done. The switching of the symbols. I fell for it again. I'm an idiot. Alright. Okay, so I did. Oh man, it sucks. Try again. I'm not gonna make a mistake then. Okay, this one's equal to 5,000. I'm gonna read it this time. So 9 times that's 90. It's gonna be 600 and 6,000. It's gonna be 200. It's equals 200. Oh, 8,000 is equals to 1,000 times 8. Then it's gonna be 40, 400, and 4,000. Okay, cool. Okay, multiply by tens. Wait, what? That's very weird. Okay. I don't know. It should be 400, right? Cool. Okay. It's 180. 280. And it's gonna be 180. Holy crap! I'm not even sure. And 320. So it's gonna be 280 again. Man, this is getting hard. Well, obviously. Whoa, whoa, whoa. Brad tried to multiply 60 by 60 by decomposing 60 to multiply. How his work is split up. Find Brad's mistake. Holy crap, okay. I think... What is this? What is this? That is the mistake, right? Okay, it's interesting. Oh crap, I'm so bad. Gonna... Joe tried to multiply 70. Okay, we're gonna find Joe's mistake. Okay, so it's right. So right. I think this is wrong. Should be 100. Step 3. And I'm not even sure what 7 should be 63, I guess. So 50 and 200. 2,000 I meant. 200. Okay, I find a mistake. Okay, so 8. Where's this? What's this 1? Should be 8 times 10, right? Okay. Okay. It's gonna be... Oh shit, I'm not even sure. Okay, cool. Next. Huh. 7-11. Just getting so hard, man. Oh my gosh, 7 times 6, I don't even know if it should be 42, right? Okay, this is 16. With... Okay, cool. And 1 8. Have 8... Holy shit, I don't even know 8 times 9. Could be 72. Okay, cool. 4 times 4 is gonna be 16. Then let's just add to your zeros. Then, simple enough, we have 800. Whoa, let's go. Bennett tried to evaluate 90 times 30, step by step. Find a mistake, okay. Okay, this seems nice. It's nice. Wait, why is it plus 10? Whoa, I'm supposed to fill in the blank? What? Oh my god, what the fuck? Oh shit, it's 1,000. Yep. My eyes. Find less mistake. Okay, so less mistake, let's see. So, step 1 should be 100. Fill in the blanks. Okay, it's 100. 54. Okay, cool. And we're gonna try it. Holy crap, I'm making a lot of mistakes. Okay, it's correct. 20,000. Did not make mistake. 20,000. Jace tried to evaluate 8 times 500. Find Jace's mistake. 40 times 100. Okay, I think she done a mistake. 100 and I don't want to be too hasty. This is correct. Let's start a quiz. Oh my gosh, do I need to redo that quiz? But no. Yeah, we're gonna try it anyway. Cody tried to multiply 38 times 40 by composing. Find Cody's mistake. It's correct. Problem is correct. He did not make mistake. So, a couple questions, okay. Which image shows 7 times 2? Okay, 1, 2, 3, 4, 5, 6, 6. Okay, it is 7, right? Okay, it's 7. Choose one answer. Which image shows 2 by 3? 2 groups of 3. Should be it, right? Okay, cool. 1, 2, 3, 4, 5. Okay. It's got a 90 and 900 and 9,000. 60 times 5 is gonna be 300. Please don't make a mistake. Oh, thank you. It's following which find all of our hot dogs. 8 and 16. Just keep count. Seven times 3 is 21. Which two expressions is the line represent? Wait, jump 5. We jump 5 times by 2's, right? Okay. And 5 times 2. Okay, let's not make a mistake. Find Claire's mistake. Okay, that's correct. Okay, that's correct. And then step is not right. Should be just by 10. Cool. Okay. So that's good. That's good.
What I hope to do in this video is get a little bit more practice and intuition when we're multiplying multi-digit numbers. So let's say that we wanted to calculate what 7,000 times 6 is. 7,000 times 6. Now, for some of you, it might just jump out at you that, hey, look, if I have 7 of anything, and here I have 7,000s, and I multiply that by 6, I'm now going to have 7 times 6 of that thing, or 42 of that thing, and in this case, we have 42,000s. So you might just be able to cut to the chase and say, hey, look, 6 times 7,000s is going to be 42,000s. And that's great if you can just cut to the chase like that. And another way to think about it is like, look, 6 times 7 is 42. And then since we're talking about thousands, we're not just talking about 7, we're talking about 7,000s. I have 3 zeros here. So I'm going to have 42,000s, 3 zeros there. But I want to make sure that we really understand what is going on here. This will also help us with a little bit of practice of our multiplication properties. So 7,000 is the same thing as 1,000 times 7, or 7 times 1,000. It's 7,000. Or you can view it as 1,000 sevens, either way. So this is the same thing as 1,000 times 7 times 6.
Then we're going to do the 7 times 6 first.
Times 6. And so you could view it as, you could do the 1,000 times 7 first, which would be 7,000, and then times 6. Or you could do the 7 times 6 first. And this right over here, this is the associative property of multiplication. It sounds very fancy, but it just says that, hey, look, we can multiply the 7 times 6 first before we multiply by the 1,000.
What?
So we could rewrite this as 1,000 times, and if we're going to do the 7 times 6 first, we could put the parentheses around that. Times 7 times 7 times 6. 7 times 6. Notice, it's 1,000 times 7 times 6. I could do 1,000 times 7 first to get 7,000. Or I could do the 7 times 6 first to get, and you know where this is going.
Yeah.
So if you multiply the 7 times 6 first, you're going to get 42.
Yep.
And you're going to have 1,000 times 42. 1,000 times 42. So you could view this as 1,042s, or maybe a little bit more intuitively, you could view this as 42,000s. So once again, we get to 42,000. And so the whole reason, some of y'all might have just been able to do this immediately in your head, and that's all good, but it's good to understand what's actually going on here. And the reason why I also broke it up this way, is that the exercises on Khan Academy make you do this to make sure that you really are understanding how to break up these numbers and how you can reassociate when you multiply them. But let's do another one. Let's say that we wanted to figure out, let me give ourselves some space. Let's say that we wanted to figure out what 56 times 8 is. And there's a bunch of different ways that you could do it. You could say that, look, 56, this is the same thing as 50. 5 tens, that's 50, plus 6 ones, plus 6 ones. So 50 plus 6, and all of that times 8. All of that times 8. And then you can distribute the 8, and you can say, look, this is going to be 50 times 8. So it's going to be 50 times 8.
What's with this distributive thing?
Times 8. Plus 6 times 8.
It's a new
plus
thing.
6 times 8. And 50 times 8? Well, 5
right?
times 8 is 40. But we're not just saying 5, we're saying 5 tens.
Holy crap.
So 510 times 8 is going to be 40 tens, or it's going to be 400. Another way to think about it, 5 times 8 is 40. But we're not talking about 5, we're talking about 5 tens. So it's going to be 40 tens. So 50 times 8 is 400. And then 6 times 8 is, of course, equal to 48. So this is going to be equal to 448. And this is actually how I do things in my head. When I do it in my head, obviously I'm not writing things down like this, but I think, okay, 56 times 8, I could break that up into 50 and 6. And 8 times 50, well, that's 400, or 40 tens, you could say. 8 times 5 tens is going to be 40 tens, or 400. And then 8 times 6 is going to be 48. So it's going to be 400 plus 48. Once you get some practice, you're going to be able to do things like this in your head. And if it helps, we can also visualize this looking at an area of a rectangle. So imagine this rectangle right over here, and let's say that this dimension right over here is 8. It is 8 units tall. So that's the 8. And this entire dimension, this entire length here is 56. So the area of this rectangle is going to be 56 times 8, which is what we set to figure out. And to do that, what we could break it up into is 50 and 6. So this first section right over here, this has length, we could say this has length 50, that has length 50, and then this second section, this has length 6. This has length 6. And the reason why we broke it up this way is because we can, maybe in our heads or without too much work, figure out what 8 times 50 is, and then separately figure out what 8 times 6 is. So separately figure out the areas of these two pieces of the big rectangle, and then add them together. So what's 8 times 5 tens? Well, it's going to be 40 tens, or 400. This is going to be 400 square units. It's going to be the area of this yellow part. And then what's 8 times 6? Well, we know that's going to be 48 square units. So the entire rectangle is going to be the 8 times the 50, or the 50 times the 8, the 400, this area, the yellow area, plus the magenta area, plus the 8 times the 6, the 48, which is 448. 448 is going to be the area of the whole thing. 8 times 56.
Oh, yeah, that's pretty cool. It's nice. Okay, I'm just gonna go take a pee. Just gonna make another round of coffee because my eyes are giving up on me. Hello. So I'm back. I made another coffee. Man, I think coffees are bullshit. Still feel so sleepy even after taking like 4 of them. Okay, so let's resume. I'm just gonna test the video if it has an audio.
In this video, I'm going to multiply 87 times 63, but I'm not going to do it just by using some process, by just showing you some steps. Instead, we're just going to use the distributive property to actually try to calculate this thing.
Holy
so
shit,
first what I'm
it's
going
not
to do,
even doing the times stance anymore.
Let me rewrite. So
this
is the
one's
same
challenging.
Thing as
Okay, let's go.
87. But instead of writing 63 like that, I'm going to write 63 as 60 plus 3. 60
no shit,
plus
that's hard.
3. Now, what is this going to be equal to?
I'm going to follow.
Well, 87 times 60 plus 3, that's going to be the same thing as, let me actually copy and paste this. So this is going to be the same thing as
87 times 60 plus 87 times 3.
60.
Oh, crap,
87 times 60 plus 87 plus 87 times 3 plus 87 times 3. You could say that we've just distributed. We have just distributed the 87. We're multiplying 87 times
distributed
60 plus
87.
3. That's 87 times 60 plus 87 times 3. I could put parentheses here to make it a little bit clearer.
Okay, I'm going to follow.
Fair enough. But then how do you calculate what this is? Well, now we can rewrite 87 as 80 plus 7. So let's rewrite that. So this is the same thing. Actually, let me write it this way. I can swap them around. So this is the same thing as 60 times 87. But I'll write that as 60 times 80 plus 7. Like this. 80 plus 7.
Holy crap, this process.
Plus 3 times 80 plus 7. Or 3 times 87. Let me just copy and paste
Holy
that.
crap, this is insane, bro.
3 times 80 plus 7. So copy, and then let me paste it, and then you have it just like that. So all I did, just to be clear, all of what you see right over here, 87 times 60, well, that's the same thing as 60 times 87, which is the same thing as 60 times 80 plus 7. All that you see here, 87 times 3, that's the same thing as 3 times 87, which is the same thing as 3 times 80 plus 7. That's just that over here.
6 times.
But look, we can distribute again. We can distribute the 60 times 80 plus 7. So this is going to be 60. I want to do that same color. Color changing is hard.
Plus
this is 60 times 80 times 80 plus 60 times 7 times 7 plus 3 times 80 plus 3 times 80 plus 3 times 7. So plus 3 times, actually let me do it, 3 times 7.
It's going to be 5,400.
So notice, what we really did is we thought about what each of these digits represent. 8 represents 80, 7 represents 7, 6 represents 60, because it's in the tens place. The 8 was in the tens place as well. This 3 is in the ones place, so it's just 3. And we just multiplied them all together. We multiplied the 80 times the 60. We multiply the 80 times the 3. We multiply the 7 times the 60, right over here. We multiply the 7 times the 3. And then we add them all up together. And this will actually give us our product.
Yep, that's
so
what I
for
did.
example,
So
this
we're
right
going to
over
get
here, 6 times 8 is 48. But this isn't 6 eighths. This is 60 eighties.
Yep.
So this is going to be 4,800. We've got 2 zeros right over here.
That's what I
so
did.
48 followed by the 2 zeros. This right over here, 60 times 7 is 4,420. 6 times 7 is 42, but it's going to be 10 times as much because this is a 60. And then 3 times 80, well, same logic. 3 times 8 is 24, so this is going to be 240. And then finally, 3 times 7 is 21. And then to get the product, we can add these two together. And you might be saying, hey, Sal, I know faster ways of doing this. But the whole reason I'm doing this is to show you that, faster way you knew how to do it. It's not some magical formula or some magical process.
Yep, that's true.
It just comes out of really distributive property and hopefully a little bit of common sense. So what is this going to be equal to? Well, we could add them all up. 4,800 plus 420 plus 240 plus 21. Well, you're going to get a 1 here. Let's see. 20 plus 40 plus 20 is 80. Let's see, 800 plus 400 is 1200 plus 200 more is 1400.
Yep.
1,400. So you get 5,481. It's equal to 5,481. And you might say, gee, this was a bit of a pain to have to do the distributive property over and over again. Is there a simpler way to maybe visualize this? And there is. You could actually write this as a grid. So we could say we're multiplying 87 times 63. We could write it like this. We could say it's 80 plus 7. 80 plus 7 times 60. 60 plus 3. Plus 3. And then you can set up a grid like this. So let me set up a little box here. It's 2 digits by 2 digits, so it's going to be a 2 by 2 grid. 2 rows and 2 columns. And then you just have to calculate. Well, what's 60 times 80? Well, we already calculated that. That's 4,800. What is 60 times 7? Well, that's going to be 420. What is 3 times 80? We already calculated that. That is 240. I don't want to do that same color. 240. And finally, what is 3 times 7? 21. You add them all together, you get 5,481. And I encourage you to now just do the same multiplication problem, the same 87 times 63, the way that you might have traditionally learned it, and see and look at the different steps and why they are making sense, and why at the end of the day you really are doing the same thing that we just did in this video. You're just doing it in a different way. And the whole point of this whole exercise, of this whole video, is so that you really get so you're not just blindly doing some type of steps to find the product of two numbers, but you can actually understand why those steps work and how those numbers relate to each other.
Amazing. Thank you, Sal, for making me understand what's really happening. I will do. Click word slow. Okay, you should have slow.
Let's multiply 6 times 7,981. And the way we're going to do it right now is just to represent or expand out 7,981 as 7,000 plus 900 plus 900 plus 80 plus 80 plus 1 plus 1. And so multiplying 6 times 7,981 is the same thing as multiplying 6 times 7,000 plus 6 times 900 plus 6 times 80 plus 6 times 1. You'd essentially distribute the 6. And to help us keep track of things, let me draw a little grid right over here. So this is the 6. And we're going to have to think about what 6 times 7,000 is, 6 times 900, 6 times 80, and 6 times 1. So I'll make a little square for a rectangle for each of them. Let me do that. So here we go. And so we just need to think about what is 6 times 7,000? Well, 6 times 7 is 42. So 6 times 7,000 is 42,000. 6 times 900, well, once again, 6 times 9 is 54. So 6 times 900 is 5,400. 6 times 80, well, 80 is 8 tens. So 6 times 8 is 48. But since it's 6 times 80 or 8 tens, this is going to be 48 tens or 480. And then finally, 6 times 1, of course, is equal to.
And then we're going to add all of those stuff.
So to find what this product is, we just have to take the sum of each of these numbers.
That's what I'm going to do right now.
6 times 7,000 is plus 6 times 900 plus 6 times 80 plus 6 times 1. So let's do that right over here. So it's going to be 42,000 plus 5,400
plus
480
886
plus 6 and we get, see, in the ones place we just have a 6, in the tens place we just have an 8, in the hundreds place 4 plus 4 is 8, in the thousands place 2 plus 5 is 7, and then finally in the 10,000s place we still have a 4. So we get 47,886. So this is equal to 47,886. 886. And what I encourage you to do is to think about how this is really underlying what we're doing here. It's not that different than what you might have done with the traditional multiplication techniques. And this is a useful way of thinking about it because now you really understand what's going on. And actually, when you start doing things like this in your head, at least for myself, this is actually how I try to tackle the multiplication problem. If someone says 6 times 7,981, if I was just looking at this and I didn't have any paper, I would say, okay, what's 6 times 7,000? I'd say, okay, that's 42,000. I'll try to remember that. What's 6 times 900?
Man,
Well, that's 5,400. Well, if I add that to the 42,000, I get 47,400. Then what's 6 times 8? 480. Have to add that to the 47,400 to get to 47,880. And then what's 6 times 1? Well, that's 6. We'll add that to the 47,880, which I've been keeping in my brain, and that's going to be 47,886. So this helps you understand what's really going on when you multiply multiple digits, and it's a useful technique for doing mental multiplication.
Oh, amazing.
I'm going to multiply 78 times 65 in a little less than standard way, but hopefully it'll make some sense and you'll realize that there's multiple ways that you can multiply. And this is actually the way that I multiply numbers in my head.
Standard way.
So 78 times 65. And then we're actually going to think about what the different parts of this process represent on this area model. So 78 times 60, 65. So I'm going to start just the way we normally start when we multiply. I'm going to start with this 5 in this ones place. And I'm going to say 5 times 8 is 40. And instead of just writing a 0 and carrying a 4 right over here, I'm just going to write the number 40. So this was the 5 times the 8.
Whoa, that's
now I'm going to multiply the 5 times the 7. And we have to be a little bit careful here.
Yeah,
because 5 times,
place.
this isn't just any 7, this is a 70. So what is 5 times 70? Well, 5 times 7 would be 35, so 5 times 70 is 350. So I'll write that down, 350. So just as a review, 5 times 8 is 40, 5 times 7 is 350. If you add these two together, this is going to be 5 times 78. Now let's go over to the 6. So let's multiply the 6 times the 8. Now we have to be careful again. This 6 is not just a regular 6, it's in the tens place. This is a 60. 60 times 8, well 6 times 8 is 48, right? So 60 times 8 is going to be 480. 480. So it's going to be 480. And then 6 times 7, well that would be 42, but we have to be careful. This is 60 times 70. So we're going to have two zeros at the end. This is 4,200, not just 42. So 6 times 7 is 4,200. 4,200, and now we can add everything together. And this is a very similar process to what we do when we do the traditional method of multiplying. I just made it a little bit more explicit what parts are from what multiplying which digits. But we can add everything together in the ones place.
Oh my
we
God,
have
5,270.
in the tens place. We have 4 plus 5 is 9. 9 plus 8 is 17. And now we can carry a 1. 1 plus 3 is 4. 4 plus 4 is 8. 8 plus 2 is 10. Carry a 1. You say regroup a 1 even, and you have a 5 right over there. So you get 5,070. Now I want to visualize what was going on here using this area model. So once again, we had 78. So I'm going to make this vertical length represent 78. So this distance right over here, represents the 70. That's the 70, and then we'll make this distance right over here represent the 8. Let me make that a little bit cleaner so you see what I'm talking about. So this distance right over here represents the 8, and then we're going to multiply that times 65. So this distance right over here, it's not drawn perfectly to scale, but it gives the idea. This is 60, and then this distance right over here, over here is the 5. So this whole distance is 65. This entire distance is 78. So when you multiply if you had a rectangle that's 68 or 65 units wide, and you multiplied it and it had a height of 78 units, then its area is going to be 78 times 65. Its area is going to be 5,070. Now each of these parts we can map to one part of this area model right over here. When we multiplied the 5 times the 8 and got the 40, that was this section right over here. 5 times 8 is equal to 40. When we multiplied 5 times 70 and got 350, that's this right over here. 5 times 70,
Holy shit.
and we got 350. When we multiplied 60, the 6 in the tens place, 60 times 8 and got 480, that's this right over here. This is
Get 5 to
60
70.
times 8 is equal to 480. And then finally, when we multiplied 60 times 70 and got 4,200, that's this area right over here. This area is 60 wide, 70 tall. So this is 60 times 70, which is equal to 4,200. And then when we added everything up to get 5,070, we were essentially just adding up the areas of each of these tiles. This big one is 4,200. That makes up most of the area. Then we get 480 from this magenta one, then 350 from this kind of greenish yellow one, and then 40 from this greenish blue one to get 5,070. So the area of this entire thing is 5,070 square units.
Yo, I got 52,770. What the heck?
What we're going to do in this video is
I can't even
multiply
do
the
the
numbers
standard.
352
What the
and
fuck?
481.
Wrong. What the
And
fuck?
we're going to do it in two different ways, but realize that the underlying ideas are the same. So first, let's just appreciate that 352 can be rewritten as 300 plus 50 plus 2, or we could think of it as 2 plus 50 plus 300 plus 300. You add these three numbers together, you're going to have 352. And same idea, 481, that's 4 hundreds plus 8 tens, which is 80, so plus 80, and then we have 1, so plus 1.
Oh shit.
And you might have be familiar with multiplying like this in the past, setting up this grid. And it's essentially we're applying the distributive property. We're going to take the 2 and multiply it times 400 plus 80 plus 1. So we're going to multiply 2 times each of those numbers. And actually, let me just draw some quick lines here. So we have that. And then we'll have, we do it like this. Then we have this. And then let me set up my grid. I'm having trouble drawing straight lines. Okay, there we go. And then one more in this direction. There you go. And then in this direction.
6 straight lines, mate.
Horizontal lines to have a neat, clean grid here. There we go. Now, first we'll multiply 2 times 400 plus 80 plus 1. So 2 times 400 is 800. 2 times, do that same blue color. So this is 800. 2 times 80 is 160. And then 2 times 1 is 2. And then we can multiply 50 times these. So what's 50 times 400?
20,000,
Well, 5 times
right?
4 is 20. And then we have another 1, 2, 3 zeros. So 1, 2, 3. So that's 20,000. 50 times 80. 5 times 8 is 40. And then we have 2 zeros.
4,000.
Just like that.
And
then we have 50
times 1.
times 1, which is, of course, going to be equal to 50. And then we go to the 300, which we will distribute and multiply times each of these,
Oh crap, it's
each
a
of
lot.
these numbers. 300 times 400, 3 times 4 is 12.
12 and then
4
4
zeros.
zeros.
1,
120,000.
2, 3,
What the
4.
freak?
We get
mate?
120,000. 300 times 80. 3 times
Yeah,
8 is
it's
24.
180.
And then we have 1, 2, 3
It's 74,
zeros.
fuck
1,
shit.
2, 3. So we get 24,000. And then 300 times 1 is,
It's
of course,
300.
equal to 300. And then what we want to do is add up all of these numbers. So let's actually add up the rows first. So if we add up the rows, let me draw another line going straight down like that. And so if we sum this up, this is going to be 962. 800 plus 160 is 960 plus 2. So this is 962. This right over here is 24,050. 24,050. And then this right over here is what, 144,300? 144,300. 120,000 plus 24,000 is 144,000.
Then we're gonna add them all
plus
up.
300. There you have it. And then you would add up these numbers just like that to get your final answer. And I'm going to hold off doing that for a second as we see the other way of multiplying these numbers. So the other way of doing it, we could have said 481, and this is sometimes called the standard algorithm, 481 times 350, we do the same colors, 352. And in the standard algorithm, the way that we do it is we start with this 2 in the ones place, and then we multiply it times 481. So 2 times 1 is 2. 2 times 8 is 16. So we put the 6 here, and then sometimes we say we'll carry the 1. We're really regrouping that as a hundreds. That's 10 tens, which is a hundreds. And then 2 times 4 is 8. It's really 800 plus 1. So that's 900. Or really 900. Do you see a pattern here? This 962 is the exact same thing as that 962 right there. Why? Well, because we multiplied the 200 times the 1 times the 80 times the 400. We saw that over here, and then we just added them all together to be 962. That's all the standard algorithm did just now. And then we move over to the 5. But this is really 5 tens, or 50, and that's why in the standard algorithm we put a 0 here before saying, all right, what's 5 times 1? It's 5. What's 5 times 8? It is 40. We regroup the 4. Let's delete this from before. What's 5 times 4? Well, that's 20. Plus 4 is 24.
Oh,
Notice,
shit.
24,050. That's exactly what we had over here. And it makes sense because we're taking a 50 and we're multiplying it times 481, which is exactly what we did right over there. And so you might guess what's going to happen when we take this 3 and we multiply it times 481. That's really a 300 times 481. Let me delete that so I don't get confused. So because it's a 300 in the standard algorithm, we put 2 zeros here first. So when I say algorithm, it just means a method of doing something. And so we'll say 3 times 1 is
what I got.
3. 3 times 8 is 24.
Sick. That's what I got, mate.
And then 3 times 4 is 12, plus 2 is 14. And so notice, I have 144,300. And the standard way of doing it at this point, we just add them all up. So whether we're doing it here or here, we just add everything up. So 2 plus 0 is 2. 6 plus 5 is 11. Regroup that 1. So 1 plus 9 plus 3 is 13. And then 1 plus 4 is 9. 2 plus 4 is 6. And we have a 1 right over there. So we get 169,312. And so when you just learn this method, the standard algorithm, some people might call it, it might seem like, hey, this just seemed like a little bit of a magic. But all you're doing is you're going to each of these places and you're distributing it. You're multiplying it times 400 plus 80 plus 1 to get this. Then you're multiplying 50 times 400 plus 80 plus 1. And then 300 times 400 plus 80 plus 1. Exactly what we did right over here.
That was just 7 minutes? Holy crap, it felt like forever. Okay, I guess we're gonna write stuff now. Whoa, okay. 1 6s. And then what is this? Then 10 6s and 9 6s. 9 6s. It's kind of 4, right? So, I'm not sure. Oh, fuck. Oh my god. Why did I write 0? I didn't mean that. Okay, so which two expressions are equivalent to 64 times 9? 69s and plus 4 9s. Plus 4 times 9. I'll try to evaluate 45 times 3. Find Alan's mistake. So 40 plus 5 times 3. 40 times 3 plus 5 times 3. It's 120 plus 15. I think it did not make any mistake. Okay. And 10. Wait, what? plus 30 and 10. And then times 4. So we have 36 over there, and for this we have 20. 156. But we made a mistake in the very first one, so we're gonna redo the whole thing. I need to be much more careful now. So this is 39s plus 2 9s, and then 13 9s is 279s, and then 288. Which two expressions are equivalent to 8 times 42? So we have 8 times 40 plus 8 times 2, that's correct. And this one's as well. Deshaun tried to evaluate 4 times 80 to find Deshaun's mistake. So 4 times 80 plus 2, okay, that's correct. Step 2 is not right. Step 2 is mistake. Fill in the blanks to solve 7 times something. So 7 plus 8, 7 times 20, 7 times 8. So oh shit, 7 times 6, I don't know, I think that's 56 or 54. It's 56, I'm pretty sure. So it's gonna be 196. Please don't fail me now, please. Oh yeah, so good. Feels good, man. Multiply 2-digit number with area modulus. Okay, that's pretty cool. What is the total area? Okay, so A is 1500. B is 240. C is 200, and D is 1432. Oh shit, I need to total everything. So that's 1940 plus 32, so 172. Please don't fail. Ah, yeah, so good. Wait, what? Is this the same shit? Oh my god, okay. It's gonna be 2700 for A. For B, that's gonna be 210. For C, we have 400. And for 35, 2, 8, 9, 10. Plus 400 is gonna be 3. Plus 35, 45. Wow! Where did I go wrong? Why is this 2? Oh my gosh. Oh crap, still the same shit. Okay. 270. Plus 200 is gonna be 910. Plus 400, it's gonna be 1310. And 45. Should be correct. Holy crap, maybe it was definitely 3 times 9 is 27, and that's right. B, it's 21. 110. C, it's 40. And yeah, 400. 35. 7 times 5. Holy crap, okay. I can't add, what the freak? I thought I already mastered it. 4, 9, 3, 4, 5, right? 4, 5. Oh my god, what the fuck? Three, 3, 4, 5. What the freak? Let me take a screenshot of this. Oh my god, this is wrong? I did the standard algorithm here and I got 3,345. What the freak? $95. Seriously? Holy crap, where did I go wrong? $210. See. Oh shoot. Should be 450. Oh shoot, man. Okay. Hey, it's gonna be 1,000. For B, we have 450. I was not gonna make the same mistake. 20, and for 6 times 9, it's gonna be 54. Yep. And 56 times 29 is gonna be 145. Alright, it's the first three are 1 to 70. Okay, then we're gonna add 54. For here, we have 2 and 6. Okay, cool. So it's gonna be 2,800. For B, we have 120. For C, we have 140, and for D, we have 6. Okay. 2,920. It's gonna be 3,020. Yep, 6. Oh fuck. I can't add. And 920. Then if I add 100, it's gonna be 3, and then add a 40, and then 6. Oh shit, this is hard. It's getting hard, man. Okay, next. We're not gonna make a mistake this time. So B, 20. That's correct. C, we have. Oh shit, I'm 7. I don't know. I think that's 63. 630. Oh shit, I'm not sure. Yeah, I think that's sure. 4 times 7 is gonna be 36. Okay. 36, 45, 54, 63. Okay, that's correct. Then totals. Add everything up. So 20 plus 630, it's gonna be 5 for the tens, and then 8. And then gonna be for 5 plus 3, and then plus 6. Okay, cool. It's gonna be 1,800 for A, and then for B we have 240. For C we have 120, and for D we have 16. So we have 18 plus 200, it's gonna be 2,000, plus 40, it's 240. Then plus 100, it's 114, and plus 20, it's 160. Plus 16 is gonna be 76. Oh yeah, that's good. So we have 70. This is gonna be 1,400, and then for B we have 80. For C, oh my god, 7 times 6 with 7 times 6. Shoot, that's 42. 420. Then am I sure about this? This is 420. Yeah, 7 times 7 is 49. Then we have 4 times 6. It's gonna be 24. Let's add everything up. But B looks so small. Ah, just right. We have 1 8 20 plus 80. We have 1 8 20. So 1 9 24. Please. Yes, thank you. Okay, last one. We have 1600. Then for B we have 100. For C we have 8 times 7, which is gonna be 56. Yep, 560. And then 7 times 5 is gonna be 35. Let's add everything up. We have 7. We add 60. We add 500. It's gonna be 2, and then 2 for the other guy. 195. Bam! So good. Give me the effects. Thank you. Next. Oh my gosh, this is hard. Okay. It's already an hour and almost a half. Hour and a half. And my progression is 29%. Okay, the following error mode is 7 times number into parts. The image not drawn to scale. Find the error of each part. 9 times 30 is gonna be 270, and then it's gonna be 63. It's gonna be 333. Yeah. I farted. I don't know if you guys heard that. Okay, 7 times 8. Oh my gosh, why am I so slow when it comes to 7 times 8? Uh, 6 to 10, 11. Wait, what? It's too much. Six one six. We do 40. The 8 and then the 48. Oh my god, I don't want to immediately press enter. But it's correct. 630 and 1 651. Great. Fill in the blanks to solve 5 times 10 or 23. Okay. Not red. Oh shoot, what's this? What? That's be 100, right? 4 6 1 5. Find Sunley's mistake. It's 9. Step 3, what the heck? What's 4? No. It's gonna be this guy, 6,000 rupees. And then this guy. $40. 3 times 600. And then so 3 times 40 is gonna be 120. And the total is gonna be 800. Plus 120, it's gonna be 923. Devin tried to evaluate 7 times 5070. Find mistake. Okay, so far so good. 5,000, correct? That's 35,000. 49. So we add the two things. Step 4. Which two expressions are equivalent to 6 times? Okay, definitely this two, because this one's definitely incorrect. Yep. Okay, last one. Please don't fail me. It's gonna be 300. Let's be 2 times 20. 16. So we have 10,656. Let's go. Distributive property, huh? Okay, I'm feeling awake now. Then you try to evaluate 3,479 times 7 using partial products. His work is shown below. Find Danny's mistake. Okay. Oh shit, I have to do this. Right. I'm gonna solve this one. Standard algorithm. Okay. So the first one is gonna be 63. Oh shit, you write it like that. Okay, man. 7 is 400. Oh fuck. 490. 7. It's me 28. Third one. For the fourth place, we have 21. Let's add everything. 3, 5, 3, 4, 24,353. Wait, what? Yeah, it's correct. Oh shoot, what the heck? He made a mistake at step 4. Use partial products multiply. Eight times 4, 8 times 0, 8 times 100, it's gonna be 800. And then we have 8 times 2000. Okay, let's go. Joe tried to evaluate. Okay, that's 16, that's correct. It's 80, that's correct. 8 times, I think he made a mistake the last part. I mean the third step. Okay, 3 times 800. Wait, what? Oh, he did the 800s. It's pretty crazy, man. 2 tenths. It's gonna be. Oh my god, it's gonna be 60, right? 2478. Please don't be wrong. Thank you. Matt tried to evaluate 49 times 24 using partial products. Find Matt's mistake. Oh, it looks about right. I think he did not make any mistake. Let's see. 4 times 9 36. 4 times 4 is 160. And then for the second one we have 29. 20 times 9, which would be 180, correct? 2 times 4, which are both, then it's gonna be 800. Let's add all this thing up. We have 1,000 here, 140 and 156. I think his total is the mistake. Step 1. Oh shit! It's possible that he did not make any mistake. I mean, if you look at this, we have 4, 5, 6, 7. I did not make a mistake. Oh shoot, I made a mistake. Step 5. I mean, four, 5, 6, 7, 76. Oh shit. Yeah, it's be 176. God damn it. Maybe I should try to start on writing things down. Two times 9 ones, 2 times 3 tens. 90 times 9 ones. It's gonna be 100. Okay, let's add things up. Oh shit, I can do this. Holy crap, I didn't even know. Two times 5, 10, 2 times 140, 300, 70. Step 4 is your mistake, dude. How do I get out of this? Okay, step 4. 1, 5, and 8 tenths, so it's gonna be 18. Then I'm gonna add everything up. So we have 5100 plus 85. Okay, just have to try this again. Find Greg's mistake. Okay, 3 times 8 tenths. It's 7 to 40, that's correct. Third. Wait, what? No! 3 times 80. Okay. 40 times 5 tenths. 40 times 5 tenths, and then 40 times 6 ones. It's gonna be, fuck. It's gonna be still 40, right? Gosh, I'm turning into an idiot. Okay, let's add everything up. So we have 2590 plus, no, it's 5. 2590, correct? Now it's 42. So we have 2 here, and then for the 4 we're gonna have 26 here. Let's be right. Oh yeah, that's good. You tried about 4. Find X mistake. 30 times 4 tenths. Okay. Oh no, not 2 tenths. Okay. 7 times 70 times 3 tenths, 70 times 5, 77 times 3 tenths, 7 times 5 ones, 705. Let's add everything up. So 2, 450, and then we have 660, then 95. Oh yeah, so good. Let's go. Oh my gosh, there's a lot more. Yeah, we're gonna finish this whole multiplication and divisions thing. Okay, start this video. Okay, I've been doing it in hard enough, so it's not enough.
Let's try to calculate 3 times 32. And I like to rewrite it, and this is one way of doing it. I like to rewrite it where I have the larger number on top, so in this case it's 32, and I write the smaller number right below it, and since the smaller number is only 1 digit, it's only a ones digit, I put that below the ones place on the larger number. So I'll put the 3 right over here. And of course, we can't forget our multiplication symbol. And this is essentially a way of saying the same thing. This is, you could read this as 32 times 3, but 32 times 3 is the exact same value as 3 times 32. It doesn't matter what order you multiply in. Now let's try to compute it. And once again, this is only one way of doing it. There's many ways of doing it, and I want you to think about why this works. So we can start, we'll start with this 3 down here, and we're going to multiply it times each of the digits in 32. So we'll start with 3 times 2. Well, 3 times 2 from our multiplication tables, and you can figure it out even if you didn't know your multiplication tables, is 6. So 3 times 2, I'll write 6 right over here in the ones place. Now, we're going to figure out what 3 times 3 is. Well, once again, we know that 3 times 3 is 9. And since I'm multiplying times the tens place right over here, I'm going to put it in the tens place right like this. So we're done. We got 32 times 3 is 96. And I really encourage you to think about why this worked. And I'll give you a little bit of a hint here.
Place values.
I'll give you a little bit of a hint about why this worked. Remember, 3 times 32 is the same thing as 3
times 30,
3 times 30 plus 3 times 2. And if you look at it that way, that's essentially what this process did. We did 3 times 2 is 6. 3 times 30 is 90. You add them together, you get 90 plus 6 is 96. Let's multiply 4 times 2012. Actually, let's make it a little bit simpler. Let's multiply 4 times 201, just to simplify things a little bit. 4 times 201. So as we've seen in previous videos, I like to write the larger number on top. This is just one of many ways of tackling a calculation like this. I'll write the 201, and then I'll write the 4 right below it, and I'll write it right below the ones place. And so I have 201 times 4. Now, just like we did when we were multiplying a 1-digit times a 2-digit, we do essentially the same process. We first multiply 4 times the 1. Well, 4 times 1, we know, is equal to 4. So we put a 4 right over there in the ones place. Then we can multiply our 4 times the digit that we have in the tens place. In this case, we have a 0 in the tens place. So 4 times 0, well, that's just 0. 4 times 0 is 0. We put the 0 in the tens place right over here. And then last, we have 4 times this 2 right over here. And so 4 times 2 is equal to 8. And we put the 8 right over here. And we get our answer, 804. Now, why did this work? Well, remember, when we multiplied 4 times 1, that was literally just 4, and we've got that 4 right over here. When we multiplied 4 times 0, that's 0 tens, so we got 0 tens right over here. And when we multiplied 4 times 2, this was actually a 200. It's in the hundreds place. So 4 times 200 is 800. So what we're essentially doing by writing it in the right places, we're saying 4 times 201, that's the same thing as 4 times 200, which is 800, plus 4 times 0 tens, which is 0 tens, plus 4 times 1, which is 4. So 800 plus 0 plus 4 is 804.
Cool.
Let's multiply 7 times 253 and see what we get. So just like in the last example, what I like to do is I like to rewrite the largest number first, so that's 253, and then write the smaller number below it and align the place value. The 7, it only has a ones place, so I'll put the 7 right over here below the ones place in 253, and then put the multiplication symbol right over here. So you could read this as 253 times 7, which we know is the same thing as 7 times 253. And now we are ready to compute. And there are many ways of doing this, but this would you could call the standard way. So what I do is I start with my 7, and I multiply it times each of the numbers up here, and I carry appropriately. So first I start with 7 times 3. Well, 7 times 3, we know, is 21. Let me write that down. 7 times 3 is equal to 21. You could do this part in your head, but I just want to make it clear where I'm getting these numbers from. What I would do in the standard method is I would write the 1 into 21 down here, but then carry the 2 to the tens place. Now, I want to figure out what 7 times 5 is. Now I want to figure out what 7 times 5 is. We know from our multiplication tables that 7 times 5 is equal to 35. Now, we can't just somehow put the 35 down here. We still have to deal with this 2 that we carried. So we compute 7 times 5 is 35, but then we also add that 2. So it's 35 plus 2 is 37. Now, we write the 7 right over here in the tens place and carry the 3. Carry the 3. Now we need to compute what 7 times 2 is. We know 7 times 2 is 14 from our multiplication tables. We can't just put a 14 down here. We have this 3 to add. So 7 times 2 is 14 plus 3 is 17. So now we can write the 17 down here because 2 is the last number that we have to deal with. And so we have our answer. 7 times 253
He wrote one in
is
this style, but the last one is
1,771.
just a simple stroke. 4-digit by 1-digit grouping.
Let's multiply 9 times 8,085. That should be a pretty fun little calculation to do. So like always, let's just rewrite this. So I'm going to write the 8,085. I'm going to write the 9 right below it and write our little multiplication symbol. And now we're ready to compute. So first, we can tackle 9 times 5. Well, we know that 9 times 5 is 45. We can write the 5 in the ones place and carry the 4 to the tens place. So 9 times 5 is 45. Now we're ready to move on to 9 times 8. And we're going to calculate 9 times 8 and then add the 4 that we just carried. So 9 times 8 is 72 plus the 4 is 76. So we'll write the 6 right here in the tens place and carry the 7. Now we are ready to calculate, and I'm looking for a suitable color, 9 times 0 hundreds plus, and this is a 7 in the hundreds place, so that's actually 700, or if we're just kind of going with the computation, 9 times 0 plus 7. Well, 9 times 0 is 0, plus 7 is 7, And then finally, we have, once again, I'm looking for a suitable color, 9 times 8, this is the last thing we have to compute. We already know that 9 times 8 is 72, and we just write the 72 right down here. And we're done. 8,085 times 9 is 72,765. Let's do one more example just to make sure that this is really clear in your brain, at least the process for doing this. And I also want you to think about why this works. So let's try 7 times 5,396. And I encourage you to pause it and try it on your own as well. Well, 5,000, I'm going to rewrite it, 5,396 times 7. First we'll think about what 7 times 6 is. We know that's 42. Put the 2 in the ones place. 4 we will carry. Then we need to concern ourselves with 7 times 9. But then we have to calculate that and then add the 4. 7 times 9 is 63. Plus 4 is 67. So we put the 7 down here and carry the 6. Then we have to worry about 7 times 3 plus this 6 that we had just finished carrying. 7 times 3 is 21. Plus 6 is 27. So we'll write the 7 here in the hundreds place and carry the 2. And then finally, we have 7 times 5, which is 35, but we have to add the 2. 35 plus 2 is 37. So 5,396 times 7 is 37,772.
Cool. Got the same answer. No.
In this video, we're going to multiply 36 times 27. So we're multiplying a 2-digit number times another 2-digit number. And the way that we're going to tackle it is we're going to first multiply 36 times 7, figure out what that is. Then we're going to multiply 36 times 20, figure out what that is, and then add those two numbers together. And what I want to do is first do this, just show you the process for how to multiply these two numbers. And then I'm going to do it again, where we're going to think a little bit more about what the different numbers represent. So first let's start with the process. So I'm going to multiply 36 times 7, or 7 times 36. So I can start in the ones place. 7 times 6 is 42. Write the 2 down here. And then the 4, which represents 40, I can put in the tens place. 7 times 3 is 21. Plus 4 is 25.
Okay, cool.
So I could write the 25 right over here. There's no place to carry this 2, so I just wrote the 2 right over here in the hundreds place. Now, let's move over. So let me clean this up so we don't get confused. So we've just figured out what 7 times 36 is. It is 252. Now let's worry about what 36 times 20 is. And so what we're going to do is we're going to throw a 0 right over here, because we're now going to multiply 36 times something in the tens place. This isn't just a 2, this is a 20. So 2, or I should say, well, let's just go with the digits right now, and then we'll think about it in terms of place value in the second time around. 2 times 6 is 12. Write the 2 right over here, carry the 1. 2 times 3 is 6, plus 1 is 7. So we just figured out that 36 times 20 is 720. And just think about what would have happened if we didn't put the 0 here. Then we would have figured out that 36 times 2 is 72, but this 2 isn't just a 2. This is a 20. So 36 times 20 is 720. And now we can add these two things, because 36 times 27 is the same thing as 36 times 20 plus 36 times 7. So let's add these two numbers together. 2 plus
same
0
answer.
is
Got
2.
Man.
5 plus 2 is 7. 2 plus 7 is 9. And we get 972. Now I'm going to do this exact same problem again, but this time, I'm going to really talk about what these digits represent. Hopefully the first pass, you kind of saw the process for doing it.
Oh, shit.
Now we're going to think
Again,
about what
grid.
these digits actually represent. So we're going to multiply 36 times 7. So 7 times 6 is 42. We would write the 2 in the ones place. And then the 40 we can write in the tens place. This 4 represents 40. 7 times 30 is 210. Plus 40 is 250. 250. Yep. And we already had that 2 in the ones place, so we get 252. 36 times 7 is 252. Now let's clean this up. Now let's multiply 20. 20 times 6 is going to give us 120. So let's write the 20 in the tens place, and then carry the 100. Or carry the 1, which represents 100. Now 20 times 30 is going to give you 600, plus one more 100 is going to give you 700. So we just figured out that 36 times 20 is 720. This 7 is in the hundreds place, 2 in the tens place. And then we can add again.
Wait,
and just
what?
like we did the last time, we got
You just did the same shit.
972.
Okay.
We now have the general tools to really tackle any multiplication problems. So in this video, I'm just going to do a ton of examples.
Old video.
So let's start off
Multiply
with, and I'll start in yellow. Let's start off with 32 times 18. 32 times 18. Say 8 times 2 is 16. I'll do it in our head this time, because you always don't have all of the space to work with. So 8 times 2 is 16. Put the 1 up there. 8 times 3 is 24. 24 plus 1 is 25. 25. So 8 times 32 was 256. Now we're going to have to multiply this 1, which is really a 10, times 32. I'll underline it with the orange. 1 times 2. Oh, we have to be very careful here. 1 times 2 is 2. So you might say, hey, let me stick a 2 down there. But remember, this isn't a 1. This is a 10. So we have to stick a 0 there to remember that. So 10 times 2 is 20, right? Or you can say 1 times 2 is 2, but you're putting it in the 2's place, so you still get 20. So 10 times 2 is 20. Works out. Then 1 times 3, and we have to be very careful. Let's get rid of what we had from before. 1 times 3 is 3. There's nothing to add here, so you just get a 3. And so you get 10 times 32 is 320. Right? This one right here, that's a 10. 10 plus 8 is 18. So now we just add up the two numbers. You add them up. 6 plus 0 is 6. 5 plus 2 is 7. 2 plus 3 is 5. Let's keep going. Let's do 99 times 88. It's going to give us a big number. 8 times 9 is 72. 72, stick the 7 up there. 8 times 9. And then you have 8 times 9 again. 8 times 9 is 72, but now you have the 7 up here.
79.
So 72 plus 7 is 79. 79. Fair enough. Now we are done with this. Let's just delete it just so that we don't get confused in our next step. In our next step, we're going to multiply this 8 now times 99. But this 8 is an 80. So stick a 0 down there. 8 times 9 is 72. Stick a 7 up there. Then 8 times 9 is 72. Plus 7 is 79. 79. 2 plus 0 is 2. Let me switch colors. 9 plus 2 is 11. Carry the 1. 1 plus 7 is 8. 8 plus 9 is 17. Carry the 1. 1 plus 7 is 8. 8,712.
Yep, got the same
Let's keep
answer.
going. Can't do enough of these. All right, 53 times 78. I think you're getting the hang of it now. Let's multiply 8 times 53 first. So 8 times 3 is 24.
1,
Stick the 2 up there. 8 times 5 is 40.
11,
40 plus 2 is 42.
4134.
42. Now we're going to have to deal with that 7. That 7 right there, which is really a 70. So we've got to remember to put the 0 there. 7 times 3, and let's get rid of this. Don't want to get confused. 7 times 3 is 21. Put the 1 there and put the 2 up here. 7 times 5 is 35. Plus 2 is 37. 37. Now we're ready to add. Ready to add. 4 plus 0 is 4. 2 plus 1 is 3. 4 plus 7 is 11. Carry the 1. 1 plus 3 is 4.
Oh, yeah.
4,134. Let's up the stakes a little bit.
Yeah, let's make it
up
harder.
the stakes. So let's say I had 796 times
50.
times
Okay, let's do that.
58 times 58. Let's mix it up well. All right, so first we're going to just multiply 8 times 796. And notice I've thrown an extra digit up here. So 8 times 6 is 48. Put the 4 up there. 8 times 9 is 72. Plus 4 is 76. 76. And then 8 times 7 is 56. 56 plus 7 is 63.
46,168. That's what I got.
I'm sure I'll make a careless mistake at some point in this video, and the goal for you is to identify if and when I do. All right, now we're ready, so we can get rid of these guys up here. Now we can multiply this 5, which is in the tens place.
Well, it could be the one
it's
we
really
made
a
a
50 times this up here. Because it's a 50, we stick a 0 down there. 5 times 6 is 30. Put the 0 there, put the 3 up there. 5 times 9 is 45. Plus the 3 is 48.
Okay, cool.
48. 5 times 7 is 35. Plus 4 is 39.
Got the same answer.
39. Now we're ready to add.
46.
We're ready to add. 8 plus 0 is 8. 6 plus 0 is 6. 3 plus 8. 3 plus 8 is 11. 1 plus 6 is 7. 7 plus 9 is 16. And then 1 plus 3 is 4. So 796 times 58 is 46,164. 168. And that sounds about right, because 796, it's almost 800. It's all, which is almost 1,000. So it's, if we multiplied 1,000 times 58, we'd get 58,000. But we're multiplying something a little bit smaller than 1,000 times 58, so we're getting something a little bit smaller than 58,000. So the number is in the correct ballpark. Now let's just do one more here, where I'm really going to step up the stakes. Let's do
Oh, you're gonna make a mistake now intentionally, right?
3 times, I'm going to do a
Oh,
three-digit number now, times 798.
three-digit numbers.
That's a big three-digit number. But it's the same exact
53798.
And once you kind of see the pattern, you say, hey, this will apply to any number of digits times any number of digits. It'll just start taking you a long time, and your chances of making a careless mistake are going to go up. But it's the same idea. So we start with 8 times 523. 8 times 3 is 24. Stick the 2 up there. Now 8 times 2 is 16. 16 plus 2 is 18. The 1 up there. 8 times 5 is 40. Plus 1 is 41. So 8 times 523 is 4,184. We're not done. We have to multiply it times the 90 and divide by the 700. So let's do the 90 right there.
Okay, let's
so it's a 90. So we'll just stick a 0 there. It's not a 9. So 9 times, and let's get rid of these guys right there. 9 times 3 is 27. 9 times 3 is 27. 9 times 2 is 18. 18 plus 2 is 20. And then we have 9 times 5
417,354 is my
plus
answer.
2 is 47. I didn't want to write that thick. 47. Let me make sure I did that one right, and let's just review it a little bit. 9 times 3 was 27. We wrote the 7 down here and put the 2 up there. 9 times 2 is 18. We added 2 to that, so we wrote 20. Wrote the 0 down there and the 2 up there. Then 9 times 5 was 45, plus 2 is 47. You really have to make sure you don't make careless mistakes with these. Then finally, we have to multiply the 7, which is really a 700 times 523. And for a 90, when it was just an 8, we just started multiplying here. When it was a 90, when we were doing with the tens place, we put a 0 there. Now that we're dealing with something that's in the hundreds, we're going to put two zeros there. 2 zeros right there. And so you have 7, and let's get rid of this stuff. That'll just mess us up. 7 times 3. 7 times 3 is 21. Put the 1 there. Stick the 2 up there. 7 times 2 is 14. 14 plus our 2 is 16. 16, put the 1 up there. 7 times 5 is 35. Plus 1 is 36.
Alright,
36.
Then add them
And
all
now
up.
we're ready to add. And hopefully we didn't make any careless mistakes. So 4 plus 0 plus 0, that's easy. That's 4. 8 plus 7 plus 0, that's 15. Carry the 1. 1 plus 1 plus 1 is 3. 4 plus 7 plus 6, that's
16.
What? 4 plus 6 is 10. 17.
Oh shit, 17. Yeah.
17.
Yeah, 417.
And then we have 1 plus 4 is 5. 5 plus 6 is 11.
7,
Carry the 1. 1 plus 3 is
4. 1,
So
7.
523 times 798 is 417,354. And we can even check to make sure. And so this is the
Why am I
moment
proud?
of truth.
This is
Let's see.
so freaking
Let's see. 523
elementary shit.
times
Key Grassham.
798. There you go. Moment of truth. I don't have to re-record this video. It's 417,354, but we did it without the calculator, which is the important point.
It's true. Whoa, okay, so we get to the practice part. Okay. Should I use this? Okay. I mean, I think I didn't need to do this. Maybe just 4, 4, 6, 8. And 20, 4. Oh shit, this one's hard. Let's not make a mistake, please. Oh shoot, it's neat. Okay, so 10, 11, 8, 9. Cool. Okay, so this one's gonna be. Let's try to do the mental thing. It's 180. 180 plus 14 is 194. Yeah, let's do the mental thing. It'll be 800. 800 plus 360. 800 plus 800 plus 360 is 1160. 1168. Oh yeah, so good. That sounds a challenge. Okay. 6,000. 6,000 plus 2,400. So that's 8,400. 8,400 plus 8,400 plus 420. 8,400 plus 400. 8,820. 8,820. 8,800. 8,820 plus 18. 8,838. Oh yeah, all mental, man, so good. Okay, Grassham. Okay, it's this one. 36 times 6. So 180 plus 36, 180. 216. Oh yeah, so good. Doing all mental math. Okay, 7 times 7 is going to 4,900. Okay, 4,921. 4,921. Oh shit, I could be wrong. Okay. Wow, this one is a challenge for the last one. Degrassim moment. Let's make this good. 9 times 7 is gonna be 63,000. We have 63,000 plus 35,000. Not 35, 300,500. 63,000 plus 350. 3,500. 63,000 plus 3,000. 63. 66,500. 66,500. 66,056. Booyah. Oh, fuck no. Wait, what? That's 63, right? So 60. Oh my god, it became hasty again. 63,000 plus 35 is 66,500. 66,556, right? Oh shit. What the fuck did I enter the last time? God, I'm an idiot. What the fuck did I do last time? What the freak? Okay. Let's gonna be 350, 385. Yep. It's gonna be 7,200. 7,200 plus 40. 7,200. 7,000. Well, it's actual 400. 7,200. 7,600. 7,600 plus 32. 7,632. 7,632 is the answer. Okay. It's gonna be 20,000. 20,800. 20,800 plus 20,800. 20,800 plus 280. 20,800 plus 280. 21,000. Shoot, where am I? Shit. Okay, 22,000, 20,800 and plus 200, 240. 240. Oh shit, it's just that's just 21,040. No, 21,080. 21,088. Shit, I could be wrong. That's correct. So this one's 78 times 5. It's gonna be 350. 350 plus 40. 290. Okay, so this one's 1,030. Yeah. So this one's gonna be 6,000 plus 2,400 is 8,400. 8,463. 8,463. Did I say? Okay, correct. Okay, for the final one, okay, it's gonna be easy. I'm not gonna write stuff. Let's say, so that's 180. Still 192. Oh, good. So good. Multiple digits. Alright, this one I need to write the algorithm. We're gonna use the standard algorithm now. 0 is gonna be 7. 0. 8, 8, 8. Oh, holy shit! Are you kidding me? Only 0 and no, it's 67. 72. I have 0, then 81. 2, 2, 8, 820. Yeah. So 43 and 82. We have 6, 8, 4 to 34. We have 6 to 35. Okay. 54, 20. It's gonna be 0, 8, 10. Okay, so 56, 4 to 20, 22, and we have 12 and 11, 4, 4, 4, 1, 4, 4. What? Are you kidding me? In 24, we have carry 2. It's gonna be 20, so 22. We have 2, 6, 12. Carry 1, 10, 11, 4, 4, 3, 1. Shit. It's gonna be 1, 2, 6, 8, 0, 2, 3, 6, 18, 24. We have 1, 11, 5, 10. We have 8, 0, 72, 0, 64, 0, 2, 1, 7, 120. You have to try again. We're gonna have to write shit. 0, carry 2, we have 42. We have 0, so then you have 4, 6, 3, 75, 8, 9, 7, 7, 9, 80. Cool. You have 8 and 48. 4, 16. Wait, what was? Wait, this is 16 plus 16, 20. 4, 32. 3, 8, 11, 4, 4, 3. Wait, what? Whoa! What the fuck? The one button doubles itself sometimes. I hate it. So, okay. 4. We should not be careless this time. Can I just reset this shit? Go back. Just one. Oh my god, can I just restart the whole thing? you have 0 and to 8. Yeah, I made a mistake there anyway. Two, 3, 9, 4. Oh shit, is this 0? Yeah, it is 0. And 6. And the 4, the 1, 5. Shit, I don't even know. 48, right? 6, 10, 8, 1, 8, 8, 8. Cool, thanks. Okay, next. Multi-digit multiplication. Oh shit, that's hard. Okay. Let's do 5, 8, 4, 4, 20. So we have literally 6, 7, 8, 0. Oh. Yo, what the fuck? Seriously? Wake up lying in a patch, 4-leaf clovers, and you're restless, and I'm naked. Gotta get out, can't stand to see me shaking. Oh, wait, 40. It's gonna be 124. Oh shit, this is a quiz, I can't afford to make a mistake. Four times 400 plus 25. 4 times 400 plus 4 times. Okay. I think. Yeah, it's kind of correct still. Yeah, it's correct. Correct. I did not make a mistake. I'm gonna double check. I don't want to do it another time. 4 times 400 plus 25. 4 times 400 plus 4 times 25. It's 100. And that's correct. That makes some sense. Find the area of each part. Find Aaron's mistake. Okay. Oh shit, he made it. Okay, 4 tenths, 2 times 4 tenths. That's correct. 2 times 8 ones, 16, 96. You did not make a mistake. Okay. Oh shit, this one I had a lot of error in this kind of activity. So it's kind of 2000 for A. And then for B, we have 120. And for C, we have 350. I think. Yep, that's 350. And for D, we have 21. Holy shit, I'm gonna double check. I don't want to make a mistake. Oh, that's 2000. Sorry. B, 120. 350. 21. Okay. 2491. Okay, alright. 6973 times 60. Okay, 6 14 19 13 18 3 4 54 8 yeah 36 31 6 2 Now I don't want to make a mistake. We're gonna redo the shit if it's definitely correct. We have 6, we have 14, we have 19, we have 13, 0 here, 63, we have 18, 7, 43, 4, 54, 58, 58, 36, and plus 5, 41. We have 6, 12, 10, 13, 9, 10, 11, 12, right? 3, 4, 4, 3, 2, 3, 2, 6. Okay, that's correct. Reason found correctly multiplies 83 times 9 using the standard operator. 8 times 7. Okay, so each of these. 7. 74. 72. Yeah, it's this one definitely. B. Molly tried to evaluate 19. Yeah. Find Molly's mistake. 1 3 ones, 3 90s, 1. Oh shit, it's 1. Okay. 90. It's correct. 50 times 3, 150. And 5, 4, and 400. 3, 4, 4, 1, 7. You did not make a mistake. Oh, yeah. Feels good, man. What's the quiz? How long have it been running? Okay, can afford more. I think I want to finish the old shit. Oh my god, it's a lot of them. Oh, okay, I finished the multiplication part. So now, after that, I'm gonna do the division tomorrow. Yeah, I think I'm satisfied for today. I finished the multiplication part of this one. Then tomorrow we're gonna do a lot of division, because yeah, that's the next thing. It's division into tomorrow. So yeah, let's just check our stuff thing. Okay. Okay, those are my notifications. 22% in the arithmetic. Okay, let's see our percentage. Yeah, indeed 22%. Missions. Still 7%. What the hell? Oh, it's probably because of the mastery. Yeah, we haven't mastered shit for the arithmetic part. So yeah, I guess that concludes for today's session. April 13. And yeah, I'm gonna continue tomorrow. Bye, thanks.